Okay, two specific examples here of graphing a quadratic just by completing the square. Because as we've seen before, there's lots of information we can deduce when it's written in this form here. Okay, so let's have a look at the first one. All right, and we're just going to start by just completing the square of this function. So we have x, whenever we're completing the square, we make it all equal to 0. X squared take 2x plus 3 is equal to 0. And we start by just moving the number over so that we can complete the square by itself. So we have x squared take 2x. And I'm going to leave a space here so that we can put in there. Now, what we're doing here effectively when we're moving 3 over is taking 3 from both sides. So 3 take 3 is 0, and 0 take 3 is minus 3. Now, what you need to add in here is half of this number squared. Okay, half of your middle number squared. That's how we complete the square. And we're adding half of it to both sides. So we're adding minus 2 divided by 2 because it's half, and squared to both sides. So over here as well, plus 2 on 2, and it's minus 2 on 2 squared. Okay, now on the left side what we have is a perfect square. Alright, and our perfect square rule says if we have x take a squared, we can write it as x squared take 2ax plus a squared. And what we notice is this is exactly what we have here. We've got x squared take 2 times a. Now in this circumstance, a is just going to be 1. Alright, minus 2 divided by 2 is just 1, and what we've got is minus 1. Minus 1 squared is just going to be 1. Okay, so what we're doing is we've got it in this form, and we're going to write it like that using the perfect square rule. So what this comes out to be then is x squared, x take 1 bracket squared, okay, and this is equal to, we've got minus 3 plus minus 2 on 2, okay, so it's going to be minus 3 plus minus 2 on 2 is minus 1, and minus 1 squared is plus 1, so we've got minus 3 plus 1, so the answer we have is x take 1 squared equals minus 2. So now let's put it back into the original equation that we have. So it's all on one side. So what we have then is y is equal to x take 1 squared plus 2. Okay. Now we can, because we've got it written in this form, it's very easy for us to graph this function. Okay. So if we have our Cartesian plane, got our x-axis, our y-axis, and our x-axis. And what this is telling us, all right, is that if we remember the green box from the previous video, the y-intercept occurs when x is 0. So if we put 0 into this equation, let's figure out what the y-intercept is going to be. Okay. Y-intercept when x is 0. So if we put 0 in here, we have 0 take 1 squared plus 2. Minus 1 squared is just 1, and so we have 1 plus 2, which is equal to 3. Okay, so we have a y-intercept at 3. So that's the first piece of information that we know. The second piece of information is the vertex. Now the vertex occurs at, if we remember the general form, y equals x take h squared plus k. The vertex occurs at point h, comma k. Okay, so in this circumstance, that's going to be 1, comma 2. So when x is 1, y equals 2. So we have x is 1 and y is 2. This is the lowest point. Okay, and of course the axis of symmetry also occurs at the point K, which is x equals 1. So what this function looks like then is this. Okay, so it's symmetrical about the point x equals 1. It has a y-intercept of 3, and the lowest point, or the vertex, is at 1 and 2. X equals 1, y equals 2. So that's how we complete the square, because when we complete the square we can easily deduce how we're going to graph a function like this one. Okay, let's look at the second example, which might be a bit more difficult. We have x squared take 5x plus 1. Okay, so again, completing the square, we want to make it equal to 0. And we move the third number over, or the c value. Okay, now we add half of this to both sides. So we have x squared take 5x. We're adding, and I'll put it in a different color. Put it in red. So what we're adding is half of minus 5 on 2. Half of minus 5 squared. And then we're adding it over here as well. Okay, and if we remember our perfect square rule from before, basically when we're completing the square, that's what we're doing. We're setting it up so that we can write it in the form x take a squared. Okay, so again, this form up here in the green, we're going from that back to here. Okay, and in this circumstance, a is just going to be 5 on 2. So what we have is x take 5 on 2 squared, and that is equal to minus 1 plus minus 5 on 2 squared. So that's going to be, now minus 5 squared is going to be 25, and 2 squared is 4. Okay, so we have minus 1 plus 25 on 4. So this is equal to x take 5 on 2 squared is equal to, now minus 1 we can write as minus 4 on 4, and now we can perform this fraction, this addition, and minus 4 plus 25 is just going to make it to 21. So what we have then is 21 on 24, 21 on 4. Alright, and now we can move it to one side and write it as the equation. So it's going to be y equals x take 5 on 2 squared take 21 on 4. So now we can graph this function. Alright, and once again it does have the form x take h. So all this same information applies. If we have y equals x take h, we have the vertex at this point. Okay, so that means this function that we've just discovered is going to have a y-intercept. Okay, well, we'll figure out the y-intercept in a moment. It has a vertex at point h and k. Now h is 5 on 2 and k is minus 21 on 4. Okay, minus 21 on 4 is about 5. Okay, it's like 5.2 or something like that. So 5.25. So we have when x is 5 on 2, which is about 2.5. So we'll say this point here, when x is 2.5, y is about minus 5, or minus 5.25. Okay, so that point there is the minimum point, and the axis of it's also symmetric about the point k, where k is 2.5. So I'll just draw our line of symmetry there. Now we just need to find the y-intercept, and we'll be able to graph that function. Now again, the y-intercept occurs when x is 0. So if we're putting 0 into the equation, we're going to have y equals 0 take 5 on 2 squared take 21 on 4. Okay, so 0 take 5 on 2 is 25 on 4, take 21 on 4. And so that's going to be 25 take 21 is 4. So this is equal to 4 on 4, which is just 1. Okay, so the y-intercept then is positive 1. Okay, so this is the minimum point here, and the function's going all the way up here through the point +1. Okay, and then of course all the way up here as well. Okay, so we've deduced what that function is going to look like based on the original function and by completing the square.